Hi folks, so for tonight's entertainment we've got this Aune T1 USB tube headphone amplifier and DAC. And this comes from a buddy of mine at work. He's had this for a while and it's developed a fault. One of the two channels has gone intermittent, and I think he said it no longer works at all in one of the channels. So obviously there's something wrong, and I figured, well, let's take this thing apart and see how it works, see what parts there are, and see if we can fix it. Anyways, the product itself looks pretty nice. You know, it's about all you could ask for like a small kind of office type tube amp just to listen to some music. You've got the option of using USB, or you can flip the switch over to line and use the audio in jacks there. Or if you want, you can actually use this as a standalone DAC and use the audio out jacks. So fairly straightforward. We'll take a look inside this in a second. Here's the power brick. You know, not much of regulatory approvals on this thing, but at least they branded it for themselves. So you know, with tube amps you kind of have weird power supply requirements. So this one is a split supply, 15 volts 0 and minus 15 volts at 800 milliamps. Alright, that's pretty much what I expected. Oh man, this thing, yep, this thing smells very strong. Kind of that enamel, well, warm, burny kind of smell. But it doesn't appear to be distressed. But yeah, it's just a transformer. All the interesting stuff will be inside the actual unit. It doesn't look like this transformer is held down at all by anything. It's just kind of flopping in there. It can move forward and backwards. Do it so the camera can see. Well, of course now, yeah, see, it's just flopping around in there. So I guess they've used this paper as a shim in order to keep the transformer from moving around too much. That's not great, actually. No markings on the transformer. You see this strain relief? It's totally the wrong size for the slot that's in the case. So they just kind of jammed it on there. Alright, well. Anyways, that's enough about that. Nothing in this supply I would consider terribly unsafe. I mean, without looking at the actual quality of the insulation between the windings and all that stuff, it's a bit hard to tell. But, you know, the wiring looks okay, I guess. The fact that the transformer just rattles around in there is probably the biggest concern. It's not even rattling around in there, so it's still pretty poor, but not so bad. So there's this tube guard here. Good idea. Just some looks to be laser cut. Alright, here's the tube. Electro harmonics. Oh, there you go, maybe you can see that. It's just a 6922, made in Russia. So of course these tubes are probably the most unreliable component in this thing, so it's a primary suspect, but you never know. Alright. Now it looks like that's interesting. It looks like they actually machined a recess for the knob. That's pretty nice, actually. And they took a spiral toolpath as well, which looks pretty cool. Ooh. These are just the gain of the amp. Okay, so it looks like the screws are underneath these plastic feet, of course. Gotta wrestle with those things. It's never... Why do people have to do that? It's not like you're gonna really see the bottom. Watch as Spag the Maker sustains a knife injury on film. At least they had the decency of using a clear little foot. Oh, come on. So what was the last one? You get complacent. There it is. Yeah, it's good that they used a clear foot so you could actually see that the screws are underneath. Alright. I like the aluminum case. The anodization looks really good, actually. How does this work? Well, maybe you have to come in from the top. Of course, I don't have my wrenches up here. Let's see how loose this is. Oh, it's very loose. Didn't even need the wrench. Or the, oh, yeah, any 16ths. How the heck? Like that. Alright, here we are. Reasonable. A little bit of a burr, but I don't think anyone cares. And they've done some precision work here. They've got these little blind holes that the main screws go into, so they don't jut out from the top. That's pretty nice. Okay. That's ceramic. Oh, that's nice. That's a ceramic tube socket, gold plated. That's pretty nice. Just a couple of capacitors, tenor. Maybe that's either the DAC or maybe the output final stage amp. Over here is pretty clearly a off-the-shelf switching power supply. Looks like they've got some goo up here to interface it to the top of the case for a little bit of thermal. Although, actually, I'm not sure that actually contacts. Take a piece of paper. Yeah, that's miles away. Never mind. Okay, so I looked up that chip. It is a Tenor TE7022L. I'll link in the datasheet in the description. And it is not a DAC. It is actually a USB audio interface. So it enumerates as a USB device, as a USB audio device, and it pumps out I2S data to some other DAC, and it can also accept data from a ADC and feed it back up USB. So it's simply an interface device. Okay, so I've plugged it in, powered it up, and we can do the Bob Anderson thing and check for glowing tubes, and that one's definitely glowing. Of course they had to put a white LED underneath. Oh well. So I hooked this up to my computer with the analog interface over here, and it's working great. Sounds pretty good. So the tube is fine. So there must be something else going on, or maybe by disturbing this thing and by taking it apart I fixed the problem. I'm pretty sure my friend wasn't using the analog stuff simply because these kind of dust caps were still on there. So anyways, I need to find a a USB cable, and we'll give that a shot. Well, sounds great. So both channels are working, but there's a very subtle change when I tap around here. The frequency response of one of the channels changes fairly perceptibly. Let me play with this a little bit and see what comes of it. Well, after throwing a bunch of test tones at this and whacking it a bunch of times with my screwdriver, I wasn't able to reproduce the problem. And I think the problem was actually in the connector here. This is a really cheap connector that I've plugged into this thing, and by moving this around I can make the audio change in all sorts of interesting ways. So I think that was it. So I had no idea what was going on in my friend's case. It could be that the tube wasn't seated correctly, or something else is messed up. Well, let's not let a working device get in the way of a good teardown, so let's proceed. Shut this thing down. I don't know what kind of internal voltages this thing is using. Suppose I could figure that out, couldn't I? This is supposed to be running on 6.3 volts on the heater. So between pins 4 and 5, there's 4, there's 5, 6.21, seems fine to me. Let's see, and then the, okay, so anode 1, let's look at anode 2, that's pin 1, and then cathode is pin 3. Check that. About 42 volts, 43 volts, seems about right. And 8 and 6, same exact thing. So no stupidly high voltages. That's good. So I was noticing, playing around with this, that my Sennheisers, not Sennheisers, sorry, Audio-Technica ATH M50s I was using to test the device, they were causing pretty severe distortion at low frequencies, so I think I'm just going to have to adjust the gain a little bit. You can definitely see another board down there. See these little rows of connectors up there. That's probably how those two sides connect. I don't know. You think this is a good idea? Feels kind of wrong. There we go. Okay. Oh, it's a lot simpler on the bottom board than I expected. Well, here's the board in question. I see two LEDs. That's fascinating because there's no holes in the case. So if anything, I'm going to guess that this is the audio signal here. Probably a ground. Yeah, that's connected to the ground plane, and you know, the left and right channel. So that is going into via there into a resistor. Where the heck does that go? Yes, okay, I see it branching off. It's going into this chip, so that's one side. And the other side flies all the way over there. Yeah, it goes to ground and then goes into the other side of the chip. So yeah, that's the audio. So it looks like they're just using this op amp here as a final output stage of some description, and then you can just set the gain by switching in some number of resistors with these little dip switches here. Okay, pretty straightforward. So what the heck is going on with these guys? These are a bunch of, these are marked Q. D669AC. Okay, so those are just audio amp. That's an NPM, and I guess, yeah, this is D69AC. 6649AC. So it looks like they're just using these guys as just, I guess, the final output. So I guess this isn't the final I guess the chip isn't the final output. It gets sent over here and amplified a bit more. It's interesting. Okay. As for the capacitors, it looks like for the audio coupling caps, no, those are not the audio coupling caps. Those are just the power supply decoupling. They're using Nichicon 470 microfarad 25 volt. For these ones, which appear to be connected to ground on one side. Okay, so this is just local decoupling for the op amp there. These are Aune branded 25 volt 100 microfarads each. Just out of curiosity, I'm going to fire up my little cap tester, and yes, testing these in circuit is not a great idea. Yeah, it's totally fine. Let's test the other side. Yeah, so those are still fine. I wouldn't expect them to be under any sort of significant stress. And then these caps here in the middle here, that's pretty clearly for some sort of audio pass-through, you know, getting rid of DC bias or whatever. Yeah, so I see like traces coming out that way and into one leg of the capacitor. Oh, you know what these might be? These might actually be protection diodes. These LEDs, they might actually be protection diodes, because I see that they're connected to one side of the signal and the other side is connected to the other side is connected to a transistor, which actually makes me think that these are temperature compensation. But I'm just throwing out random theories. LEDs, if I remember correctly, have a opposite temperature coefficient from regular silicon, so they can be used to offset temperature changes if you want a nice stable circuit over a wide temperature range. Interesting. Okay, so I've had a bit of a look around and I think I understand most of this, at least the high level overview of this board. Alright, let's start with the power supply. So if this is the power supply connector, you get directly a transformer output here, so plus minus 15 volts AC at 60 hertz. You got a full wave rectifier there, you know, an inductor, a couple of caps, dumping directly into these big Lelon brand, which I will note is not well regarded as a brand for capacitors, but 3,300 microfarad 25 volt tank, and then that's farmed out into several power supplies. There is one over here. This is a 5 volt supply, this is a 3.3, and then there's this switching power supply up here. If I had to guess, I'm pretty sure that this power supply here is to feed the filament, because it's actually fairly high power as far as these things go, relatively speaking, and it doesn't need to be particularly clean. So I'm thinking that's the filament supply, but we'll check that. you could boost up the voltage of either one of these. Sorry, you can actually fixed voltage regulator chips like this. You can actually bump up their voltage output just like you would an adjustable voltage regulator. You just can't go below their rated voltage. So this 5-volt one can definitely be bumped up to 6.3 if necessary. Same with this 3.3, but I don't see why they would do that, especially because these are a bit teensy given the power requirement of the filament. Anyways, so moving over here, so we've got the USB connector here going into that tenor chip, which is tied into this Burr Brown PCM 1793, which is kind of the brains of the operation here. It's a very nice digital to analog converter. That's a $5 part in one-off quantities from DigiKey, approximately. So there you go. So that's generating the audio output. This chip down here is marked ATML U108. Which I couldn't find any information about. Initially I thought it might be some sort of microcontroller. These traces here connect directly into this tenor chip, and I looked up the pinout, and those are I2C lines. So this is doing some sort of I2C. I kind of lose track of where the traces go, but maybe that's a microcontroller, maybe that's a little bit of memory. I'm not sure. Moving along, over here we've got kind of the analog audio amplification stage. We've got a pair of, a complementary pair of positive and negative 15-volt regulators here, 79M15G and 78M15G, with a little bit of bypassing and a couple things like that. This is a 2134UA high quality audio op amp, so that's probably conditioning the audio either directly from here or after the tube. I'm not entirely sure. That all kind of funnels around over here to the tube socket. A little bit of decoupling. Oops. These are Nichicon brand, so they definitely have they've optimized where they could for cost, I guess. Over here, there's just a little small signal relay. This thing waits to enable the headphone out until I think 30 seconds have passed to allow the tube to warm up. And that about sums it up for this board. I notice here that these header connectors are just manually cut off. Let's see if you can see that. See, they're not the correct size. Someone's gone in and cut off the excess. So yeah, no big deal, but you know, that would have cost some extra time. Someone needs to go in there with a little fixture and snap off the correct number of pins, and you know, they haven't done a great job because that break isn't particularly straight. Oh, there's a little solder bead there. That would have caused a problem. Just stuck to the side of that cap. 12 megahertz crystal, and that's about it. Alright, so I'm kind of curious where that 6.3 volt supply is coming from. So those pins are definitely connected to the heater. Alright, well, that's about sums it up there. I'm going to give it a once over visually to see if I see any visibly broken solder joints of anything of that nature, but it seems to be a winner. We'll see if it plays up in the future. But overall, I think it's a pretty nice little board. Can't complain too much. It's pretty well laid out. Everything's kind of logically arranged. It's not too squashed together. They weren't trying to make this thing as small as possible. You know, this is quite clearly the analog section. All the parts are nicely arranged. You know, there's a nice symmetry about it. Pretty easy to follow. Well, well, well. I'm sure glad I took the time to make that pass, because I see a problem. Do you see it? A little solder ball bridging out to the pins there. Nice. Starting to wonder. I really am. I also see signs of a little bit of rework up there, so I'm not convinced they use the best PCB manufacturer house. And yes, in case you were wondering, the LEDs glow. One last thing before I put this thing back together. You might be wondering where the about 45 volt bias for the tube comes from, and it's probably from a voltage multiplier, a very simple one, a Cockcroft-Walton ladder. So you only need 2 diodes and 2 capacitors to achieve such an effect. You take a AC voltage and you just double it and you get DC out. So I see some diodes there, and a couple diodes there. So if somewhere in here there's a voltage doubler, most likely. I don't see any switching supply to generate that high voltage, so that's what I think is happening. Alternatively, given that 45 volts is pretty close to 30 volts, they might be doing something weird with the AC coming in, because remember, it's plus and minus 15 volts, so a 30 volt differential. So maybe just rectifying that and taking the very peak is enough. Yeah, so multiplying 30 volts times the square root of 2 to get the peak voltage is 42 volts. So actually, I take that back. They might not be using a voltage doubler. They might just be literally taking the output from the transformer, rectifying it, and that's it. It is a bit higher in the actual circuit, but it's entirely likely that the transformer outputs a little bit more than 30 volts peak to peak. We can test that. Okay, so to test that theory, if you recall, the AC waveform goes directly into this bridge rectifier and into these caps, and there's one cap per side of the center tap. So you've got 0 to 15 going to this one and 0 to minus 15 going to this one, and these two are actually connected together in the middle. As you can see, they're both, this big ground plane here is connected to both of these caps. So if I just take my meter here and measure across both of the caps, I should get about 45 volts. And I get 22 because I forgot to turn the power on. There we go, 46.6. So see, if I measure across these two, I get, 23, and in total 46. So never mind about the voltage doubler. If I remember rightly, the tube amp that I built a while ago uses a voltage doubler, but this one has figured out that 45 volts or whatever is plenty, and the power draw at the oh look, it thinks the tube is warmed up, turned on the LED over there. Anyways, the power draw for the bias is minimal, so clipping off the top of the AC input is just fine. Turn that thing off. You can hear the relay click. And alright, let's put this thing back together and see if it still works.